Okay, okay. Entonces we have 4x minus 7 plus 2c equal 19. Basically, we have 4x plus 2c equal 19 plus 7, no? Okay, it's 26. 26, that's 4x plus 2c equal 26 divided by 2, I know. By 2. It's 2x plus c equal 13. Just one more time, I solve for x. I have 2x is equal 13 minus c divided by 2. Actually, we have, let me copy here, y, I don't know, x is equal, here, I want to copy here, 13 over 2 minus c over 2. Okay, so now I want to declare a new parametric equation. O sea, x, who is x? Bueno, x is this expression, 13 over 2 minus c over 2. Who is y? Well, y is this expression, is 7 minus 2c. And c is c. Because what is the idea? The idea is I define c like a parameter, not t. The name is not important. So the most common word que the book using in this part is t, is s, I don't know why, it's lambda. Pero I use c, and c is obvious que vary because it's infinity line in both directions from negative infinity to positive infinity. Entonces, the thing in the fly in the air is, bueno, professor, and this is the same. The answer is, of course, the same. Entonces, the thing I want to illustrate is the parametrization for any object in mathematics is not unique. So there are different possibilities to do that. Entonces, now, suppose que by curiosity, I want to prove que this parametrization and this parametrization are equivalent and represent the same line. Okay, there are many ways to do that. One way is, well, I go to GeoGebra, I put both in the GeoGebra, and you see it's the same. Wow, amazing! It's one possibility, and another possibility is algebraically. I suppose que, well, either way. For example, let me see. Okay, let's go. No. Let me explain one thing first before go to the GeoGebra to see the big picture of this. Look, in GeoGebra, there are many ways to do the line. However, the most efficient way, in my opinion, is using one function that is called curve. And curve is using not only for the line, using for any curve in 3D. Okay, I promise that next week we study in detail the curve. Entonces we have different separated by comma. Different equation, no? For example, in the first here I put equation for the x. So x like a function of t or c, whatever the parameter, the name of parameter. You put here the y as a function of t or c, depending on the parameter we're using, and c as a function of t. We have another space here in the function curve. I set 1, 2, 3 parameters, and this is the parameter que es t or z, depending on the problem, no? Comma, and after the minimum and maximum value, minimum, comma, and maximum value. And close the parenthesis, press enter, and you see the line. Minimum, I suppose we say infinity to positive infinity, we suppose we're negative 100 to positive 100, right? This is the syntaxis in GeoGebra to define not necessarily line, any curve. Let me switch, guys, to GeoGebra, and you see clear the problem. Let me try to do my best. Carajo, where? Okay, here. Oh, okay, now share screen to GeoGebra. Boom. Boom. Do you see GeoGebra? Good. Look, we have a point that's given. I flash it. The point I call A, 5,1,3. We have a vector that's given, bang. Flash it, right? This is the only information I give you at the beginning. Well, using the vectorial equation, parametric equation, I type in this curve, and you see x equals something, y equals something, z equals something, the parameter is t from negative 100 to positive 100, bam, and this is my line. Look at the line. The line passing through the point A, and also is parallel to the vector direction is given. Okay, not bad. However, in one moment of the game, I discovered that one possibility of represent this line is the intersecting two planes. So I put the equation for the plane here. Look, this is my first plane, blue plane, and this is my second plane, green plane. And the intersection, look, is also the line. So one possibility, right? Now, using algebra, I discovered another possibility of parametrization. This line is this. Okay, suppose I delete that. Yeah, I put this in another color, no? Ah, look at this, it's the same. Do you see it's the same? Fantastic, guy. But I want to show you more. In this elementary problem, when it was easy or relatively easy, manipulate the system like a pre-calculus to determine the intersection of the two planes is a line using basic algebra, you know, substitution. And sometimes no, sometimes it's very complicated. So I propose one fantastic way using matrices. How you can use a matrix? Well, for example, you click here and this button can represent three horizontal lines. You go to the view. In view, you select spreadsheet and cast. Of course, you continue the other case algebra and three-dimensional graphic. No? Now, I want to illustrate. Okay, good. I did that, no? I want to illustrate. Look, we have now 4 windows. Wow. This is a spreadsheet. This is three-dimensional graphic. This is algebra, and this is cast. Now, in a spreadsheet, I just type in the system. The plane, no? 4x minus y, z is missing, equal 19. And the other is the same. X is missing, 2y plus 4z equal 40. If I select this number like that, right click, no, select first, right click, and you select create. Create what? Create a matrix. And this, when you create a matrix, automatically you can see in the algebra part here, our matrix. This is our matrix. Look, okay, default, GeoGebra declare like matrix 1, M1. Okay, you can change the name you want. Click here, rename. Okay, no, it's okay for me. Now I go to CAS. CAS is fantastic because CAS allow us to perform complicated operation with the algebra. Entonces now I using this function, look, reduce row echelon form. I suppose you remember, so the teacher explained this. Okay, you type, you don't know, you type reduce it. Look at that, reduce echelon form. I did that before, no? You click here and you include the matrix N1, que es the matrix we have in the game, no? Matrix N1, boom, you press enter, bam, and you get this, que is exactly the same, the equation and parametric, right? Look, the first parameter is 1302 minus 1 half t, because I suppose que I put t here, but actually in the paper was not t, was z. But it's the same. So the name of the parameter is not important. It's totally irrelevant. Guys, do you understand or look like super complicated? Question, come on, I want to hear opinion. Omar, oh, Omar. Jennifer, Claudia, it's good. Okay, Ricardo is good. Jocelyn, remember, guy, start working in the homework as soon as possible. No? This is Chinese or Japanese? Who is mathematics? Huh? Do you see the whiteboard now? No? Okay, it's good. Okay, super, super, super. I suppose I am working with the advanced student, no? Therefore, I understand very well. Okay, okay, okay. Okay, share the screen. Mathematicity. Wow. Okay, switching to... Okay. Okay. Oh, okay. Finish this problem. Too long. Let's do another problem. Okay, bring here for you. It's about just the plane. Okay, I need to find the equation of the plane. Find the equation of the plane that pass it through the points. Entonces give me 2 points. P point, P is equal 1, 3, 2. Comma, another point I call Q, que es the point 3, comma, -1, 6, comma, R, que es the point 5, 2, 0. Okay, 3 point. We have 3 points in my hand. P, Q, R. P, Q, and R. You know, using the common sense, no mathematics, que 3 points define a plane. Yes or no? Right, in the 3-dimensional space. Okay, define the plane. Not necessarily like that. This is the smart board fixed this rectangular, no? But no. Okay. But what is the? I asked a question for you now. What is the piece of information that we need to define a plane in 3D? What is the piece of information that we need to define a plane in 3D? Come on, guy, answer me. Come on, using the chat or activate the microphone. What is the piece of information that we need to define a plane in 3D? Nobody remember that? You have totally erased the brain. Come on, check it out in the notebook. What is the piece of information that we need to define a plane in 3 dimensions? What piece we need? We need something. You remember my hand and the pen? Do you remember or you don't remember? What the hell happened here? Daniel Giraldo left. Why? Okay. You don't remember? Definitely no. Say, I need the answer. Yes or no? Wow, what's going on?
No, professor.
Come on. No, remember?
No.
Okay, no problem. I am a teacher, I explain. Okay. We need a point. The information that we need, number one, is a point. 1 point. But we have plenty points. Well, we have 3 in your problem. But we need the normal vector. Do you remember now? Normal vector. No direction vector, normal vector, que es a vector perpendicular to the plane. So suppose que this is a plane. Okay, entonces it's a normal vector like that. Not necessarily unit vector. Any normal vector. Okay? Entonces what should I do? Okay, image. Image, what is image? You take a picture. No. I recorded the video. Don't waste the time with the screenshot video. Accident. Wow. What happened? Accident. You don't understand, guys. Apologize. Wow. Pay attention. Focus in the lecture. This is important. This is hard. This is not for the all of people. No. Okay. The comment is about the lecture. Mathematics accident. What is that? Apologize. What is that? Okay. So we need 1 point and we need a normal vector. Okay. Somebody can help me to understand how you find the normal vector. Normal vector is a vector. This is a plane, no? This is a plane. Normal vector is a vector. Okay, you see, for example, is out the whiteboard or in whiteboard. You have two possibilities of the normal vector, no? Suppose the vector you can see like an arrow like that. This is the vector, and you can see this is my eyes, and this direction you see something like that. Boom. See, you see in this direction, this is my eyes now. You can see like that. Okay, because you see that part of there. Entonces, how you find one number vector? No idea? Okay. My second question is, how do you find normal vector? Bam. Okay, my first question is how many pieces of information and what piece of information we need to define the plane? It's 1 point and normal vector. How you find normal vector? No idea? No idea? Wow. Okay. Suppose okay, I select 1 point like a pivot. Pivot is the most important point. I define one vector here. You know very well how you find the vector in between 2 points, no? A subtraction, the component, no? And this is the vector PQ. Let's do it. PQ vector. PQ vector is subtraction. This is a vector, angular bracket, no parentheses. Entonces es you subtracting. Remember, I suppose que the Q is the arrow of the vector and P is the starting point, no, of the vector. And you're subtracting is 3 minus 1 is 2, comma, -1 and -4, comma, and 6 minus 2 is +4. Everyone follow me or you are lost? Okay, es vector between 2 points. No position vector, sino vector between 2 points. 2 points is given, you're subtracting the component. In what direction? Well, I suppose que Q minus P, because Q is the arrow, P is the starting point. Likewise, I find another vector here, que es PR, no? Que es PR. PR vector is subtraction, is 5 minus 1 is 4, comma, 2 minus 3 is -1, comma, 0 minus 2 is -2. Okay, so I have in my hand two vectors. This vector lie in the plane. In the plane in which I want to find the equation, because my goal is find the equation for this plane, no? But we need normal vector. To find the normal vector, I perform cross product, because I know because we have one vector here, another vector here, and you perform a cross product, we get the second vector, or the third vector is perpendicular to the another vector, no? I don't know, depending the direction I take the cross product, maybe it's like that or maybe like that. I don't care if it's down or up. This doesn't change our equation. Okay, so we have two possibilities. In this case, I perform PQ cross product. PR. Okay. Let me see. In this case, PQ. Using, remember the hand right rule. PQ. I put my hand right, my finger pointing from P to Q. I blend my finger to touch the R point, so I can see in my thumb point out the plane. So the direction of this vector is like that. Bang, not like that. Making sense, right? And to compute that, this is the mnemonic device to compute the Doppler IJK. Let's do it by hand one more time. However, I highly recommend doing in GeoGebra, or the student can have the TI-89 calculator. We have operation with the vector to say you are doing Okay, guys, this is important to understand. We are living in the United States of America, and we are living in the 21st century. Therefore, the mathematics using one pencil and one paper is history. We're using software, okay? We're using technology, okay? The pure mathematician spend 2 weeks doing this problem. No, the future of the engineer and scientists is technology, okay? You don't waste the time doing this stupid operation by hand, okay? This is my opinion. I respect another opinion, no? Okay, so now let's do it by hand, because I want to illustrate one more time. I did before. This operation is I. So you expand the determinant using the first row always. And in this case, is negative 4, 4, negative 1, negative 2. Minus j. J is always negative. The determinant 2 by 2 is 2, 4, 2, 4, 4, negative 2. Okay, the cofactor associated with this guy. Plus k. And the last cofactor is 2, negative 4, 4, and negative 1. Do you follow me? Do you follow me? Do you follow me? Eso, bueno. Carlos Duque dice, yes, okay. Okay, now compute quickly. Quickly. This is 8. Okay, negative 4, negative 2 multiplication. 8 plus 4. Because when you multiply, the diagonal case goes up and negative extra. Go down, no. Minus j. This is negative 4. And this is negative 16. Plus k. And this is negative 2. Plus 16. Because double minor, no? The minor, when you go up and negative, double negative become positive. So actually we have 12i. This is 20, pero negative. So another double negative become positive. 20, 20j. And this is 14. 16 minus 2, 14. This is plus 14, plus 14. Okay. If you want to express it, this vector in the other more comfortable notation, at least for me, is 12, 20, 14. Okay. I have the normal vector in my hand. However, I can see, not necessarily simplification, but you can, of course. I can see, for example, this vector is divisible, is the even number, 12, 20, 14. You can divide it by 2. Entonces, the new vector after the division by 2 is 6, 10, and 7. Do you see that? And you know that the relationship between the vectors is the same because they are parallel. Okay? So I'm using this because it's easier, because the number is small. No? Okay? Done? Now, remember the equation of the plane. The equation of the plane is A x minus x null plus b y minus y null plus c minus c null equals 0, no? Because this comes from the dot product of the normal vector. Okay, this is ABC. A, B, C is the normal vector. So basically, I have 6 x minus 1. Remember the point. I select when I select one point. I need to select one point, no? I select the first point, P. P. I select P. Either point. Any point is possible. Okay, P is the point 134, 132, sorry. 132. Entonces plus 10, que P, plus 10. Y minus 3. Plus C, que C is 7, C minus 2 equal to 0. And that's it. No. Well, almost. The rest is super easy algebra. Distribute the property, combine like term. 6x minus 6 plus 10y minus 30 plus 7c minus 14 equal to 0. And you organize the plane equation of the plane in the same way that we are using in algebra. Ax plus by plus cz equal d. So I move, for example, I put it to 6x plus 10y plus 7c. So we move to the right hand side. 14, 30 and 6, no? It's 20, it's 50. 6x plus 10y plus 7c equal 50. End the story. And this is the equation of the plane can satisfy this condition. Curiosity. No, we have, this is for you, work for you. I have no time, never. So you plug in any initial point and the equation satisfy perfectly this equation. Because this plane contains this 3-point PQR. End the story. Any question? What part you don't understand? Okay, summarize. To find the equation of the one plane, we need 1 point. We have 3 points, enough, and 1 normal vector. How you find the normal vector? Well, you find the vector in between 2 points. It's easy, the formula that we studied the first day. Now you perform a cross product, because I know the answer for the cross product is always perpendicular to the PQ and PR vector. And you have one normal vector que you see the location is out the whiteboard, no? After using the formula and end the story. The formula in vectorial way is R minus R null dot product normal vector equal to 0. This formula is a vectorial. Okay, I put it here in more, understandable. Okay, who is ABC? ABC is the component for the normal vector. Who is this? Well, this is component by component, x minus x null, y minus y null, exactly like the component by component. Bam. It's the same idea. Any question? Come on. It's a moment to ask me a question. The plane to top left has circle. Okay, activate the microphone because it's confusing this note. Activate the microphone, mister, and ask me directly. Come on. What is it?
You had the plane there with the little circle with the dot in the middle, and then you had a circle with the X.
The little circle indicate direction of the normal vector. So this little circle, you say this circle?
Yeah, which one is the one that's like towards us out of the screen, and which one's inside towards the inside the screen?
Inside, let me see. Okay, this vector, okay, using the handwrite rule, this vector cross product. This vector is outside. It's outside. It's outside. No inside. It's outside. It's outside. This is your question, Mister. Daniel, torque. What do you say, torque?
I'm sorry?
What do you say, torque? Es la que static.
Static torque.
You took static?
Oh, no. I took a physics one.
Ah, physics. Okay.
Yeah.
Okay, entonces, ¿was clear my answer or no?
I know, I get that. It's just a notation. Which one was the one that was like towards us? It's the one with the dot in the middle.
Yeah.
Notation. Okay, that's towards us. Okay.
This is okay. You need to update my notation, no? Maybe another teacher apply another notation. Sorry. Okay. Any other question? Do you understand or you are totally lost? We start with the 24 students at the beginning. And now, after the second lecture, 2 students withdraw. But incorporate 2 new students. Wow. Where come from this student? I don't know. It's important. I suppose that you study in another university, no? No, in Miami-Dade College. Or in Miami-Dade College. Okay. After we conversation this. When we continue now, we continue important. So far, we study line, we study plane, we study point, we study circle. Now, let me try to manipulate the relationship between this object. For example, I want to discuss now distance. Another topic, guy. Distance in between point and line. Okay. Distance between. So this suppose que one problem give me 1 point and give me 1 line. Suppose we have a point P and we have a line L. Yeah, I want to find the distance. Distance is, you know, distance is this 90 degrees. Okay, is the minimum, no? Distance, because we have distance here in different point. Pero no es minimum distance, no? Es the equidistance. What is the minimum distance? What is the shortest segment connecting P and the line? This is the idea now, right? Okay, so now it's relatively easy because the information we need, we need the point. We need the point P. We need the line, and the line is present parametric or vectorial, either way. However, we can find 1 point of the line that I want to call A. Okay, it's super easy because, for example, in parametric, you can see, for example, the parameter T you evaluate in 0, in 1, or in 2, and you remember the parameter. When you vary the parameter, you move the point A onto the line. Entonces you can determine, for example, one vector here. Okay, this vector is AP, no? AP vector. So because the algorithm is, we have a point P, we have the line L. We can determine one extra point on the line. Okay, I call A. Okay, I have the second point. Using A point and B point, we can determine the vector in between 2 points. Okay, I call AP. Now, in order to find the distance, I using projection. But what kind of projection? Remember, we have 2 projections. We have projection vertical and we have projection horizontal. Okay, in this case, what do you think? What projection we use? Projection horizontal or projection vertical? Let me recall something. Vertical, of course. Giraldo. Okay, look. Very well. We have, for example, this is the classical triangle. No, no good. Okay, we have a right triangle, suppose a right. And also this is projection is using dot product because it's cosine theta, but this is cross product because it's sine theta, no? Okay, to find projection, another way I want to explain now. In another case, we don't study the cross product in this moment. So I'm using the subtraction. This is the horizontal projection. No, I don't want now in this problem horizontal. I need vertical projection. So now I'm using the cross product because I know que the connection, the cross product is sine. And this is obvious que si this is theta, our famous angle, this is a sine, the hypothesis, no? Okay, so basically, what is the formula to find this distance? This distance is, you take the vector AB, you perform a cross product with the vector B, que the vector B is given because we have the equation of this line, this is the equation, no? And divided by the magnitude of the vector B. Boom, that's a formula. Okay, good. This is confusing because remember projection. Projection is relatively easy always because when you want to project in maybe vertical or maybe horizontal, the first thing you should do is find the univector and the direction that you want to project in. In this case, is the vector direction of the line. So you perform the dot product, entonces you get the horizontal projection. However, if you perform the cross product, you get the vertical projection. But in this case, when you perform a cross product, of course you get a vector. And the thing I want to find is no vector, is a scalar. So now I need to find magnitude of this. Okay, this is the formula. Suppose, well, professor, I don't like the formula. Okay, using your common sense. You find extra point, boom. You determine the vector in between the point, boom. And you perform cross product with the univector in the direction of the line, boom. And you find the magnitude, done. End story. Okay, let's do an example. Okay, suppose a point, one point is given, P. It's example 2, no? One point is given, que es a point 4,4, 1. And one line is given, and parametric. 1 plus 2t. Sorry. X is equal 1 plus 2t. Y is equal 7 minus t. And z is equal 5 plus 80. Okay, this is information that's given. A point, one arbitrary point in 3D, one line in 3D. Okay. I need to find the shortest distance in between this point. Okay, I use my formula or no. Okay, first of all, I propose you find 1 point on the line. I want to call A. It's easy because you take this number, look, 1, 7, and 5. How do you know that? Well, you know because suppose que t is 0. Entonces, this point is a 1,7,5 belong to the line at t equals 0. You can take another. Of course, you can take another. What is the difference? The difference is que suppose que A here, another point here, another point here. Okay, it doesn't change the answer, right? Now you determine the vector between the point, AP vector. AP vector is subtraction. Subtraction is, suppose, doesn't matter what you're subtracting. Well, in this case, I don't care que es AP. So the direction is not extremely important. Si es en this direction or es en this direction. This is no big deal. So basically, you're subtracting. In this case, 4 minus 1 is 3. 4 minus 7 is negative 3. And 1 minus 5 is negative 4. Suppose que you are doing opposite direction. Well, okay, entonces no AP, es PQ or PA. Entonces the sign is completely different. But this doesn't change our problem, our answer, our final answer. Okay, now the direction vector of the line. What is the direction vector of the line? 1 is 2, negative 1 and 8. This is the direction vector of the line. And immediately you find the magnitude of this vector. It's a square root, 2 squared plus negative 1 squared plus 8 squared. It's 69. Square root 69. Okay. Now, the most complicated part is the cross product. Okay, I don't want to waste the time doing that. So you are doing this. Look. Basically, the distance d, the shortest distance d, is actual value of the cross product between 3, negative 3, negative 4. Cross product. Guy, the cross product we can do using calculator. We can do using GeoGebra. If you want, I try to explain now. But as you know, I hit switching to the another screen. Oh. Okay, entonces you multiplication cross product this vector and this vector, que es the vector, this is AP and the vector B is 2, negative 1, 8. And find the magnitude of this divided by the magnitude of vector B, que es square root 69, ¿no? Entonces, this is a long process. Okay, you put the determinant or GeoGebra or calculator. Yeah, I found okay, the answer is square root 1817 divided by square root 69. Okay, rationalization a little bit, you know, put together, and one radical is 237 divided by 3. Okay, this is approximately, you know, to have some idea what is the shortest distance. This number is irrational, it's crazy. Entonces 5.1316. Okay, let's just apply the formula. Or the complicated part is the cross product. The cross product. Let me try to do for you at least one time in your life the cross product using GeoGebra. What is the disadvantage of GeoGebra? Okay, GeoGebra give me the answer in decimal approximation, not in exact answer. Okay, guys. Let me try. Okay, let me try. Okay, basically is this vector and this vector. Okay, let's move on to GeoGebra. Okay, and create new file, new. Boom. I save my Word. I create new. Okay. Let me switching. Share the screen to the GeoGebra. Okay. Bam. Okay. What the hell is that? Okay, I create one new one, but until I go to view. View. I need only not spreadsheet anymore. Spreadsheet for the matrix, cases for the matrix. Just algebra and 3D view. Okay, close this. Close this. Okay, good. Now I don't like this gray plane. I delete that. I put a vector here. Look at the vector. The vector that we have in our hand is, okay, remember, in GeoGebra, the vector, you put lowercase letter. I don't know, let me call A. It's equal. Okay, wait, sorry, do you see GeoGebra? Yes or no? Yes or no? Good. Okay, okay, done, thank you. Entonces, paréntesis, es 3, coma, negative 3, coma, negative 4. This is my first vector. Boom. You can see the representation here, the black vector. And the vector B, que es the direction vector, no? Is equal to parenthesis. GeoGebra understand que es a vector because I use in lowercase letter. Si I use in capital letter, entonces GeoGebra understand que es a point. 2, negative 1, 8, no? 8. Okay, this is the now I perform the cross product. So the cross product, okay, listen, you type in cross, capital C, cross product. Cross. And you, when you finish, you don't finish cross product, you see here, cross vector, comma vector. You select that. What is the first vector? A. What is the second vector? B. Press enter. Boom. The answer is 28, 32. And 3. Okay, good. Now you compute the magnitude of this vector. And magnitude look like absolute value, no? Entonces, no, actually, actual value I select here directly in the keyboard for Desmos, absolute value of U. Okay, is 42 point something. And absolute value of, well, let me press enter. It's called B, and the absolute value B, que es the direction vector, no? B is 8.31. And finally, you divide B divided by C, no? So it's B, division C. Bam. And the answer is 5.13. We are the best. Okay? Okay, this is the most important for me is the procedure. Okay? What is the only disadvantage of this way? Well, the only disadvantage is that the answer is in decimal. Maybe in the MyLab homework and test, they don't want the approximate answer, they want the exact answer. So the exact answer, well, so you need to compute it with the calculator. So I highly recommend using TI-89. I promise, because we are put together, agree, I create the workshop for the TI-89, but it's not too long. It's in 10 minutes I explain every operation with the vectors, because TI-89 is the only calculator that have operation with the vectors. It's super easy. So you declare a vector and you perform cross product, dot product, whatever you want, unit vector, and that's it. Any question, guys? Do you understand this problem? The shortest distance between the point and the one line? Good. Okay, so I want to complicate more your life now. Suppose Espérate, let me see si I share the whiteboard or no. Switching to whiteboard. I suppose this is whiteboard. Okay, now. Entonces I study relationship between point and line. And I want to study now relationship between two lines. So what are the positions, the potential or the possible position in between two lines? Well, maybe we have intersecting line like that. It's an intersecting line. What means that? Okay, both lines lie in the same plane. Remember, we are talking about 3D and have a common point. It's an intersecting line. Pero es obvio que si don't lie in the same plane, there are no common point. Okay, we have parallel line. Parallel line. Well, in this case also we can find, if you want, the common plane because lie in the same plane, but never cross, never intersecting. And finally, the skew line. Skew line is the most common case. Skew lines. Okay, remember we are working in 3D. The skew line is a one line completely different to another line, saying in different plane and never intersecting. This is the most common. So suppose 99% of the case is a skew in 3D. It's very, very weird intersecting, pero happen. And parallel is also weird. Maybe 0.5% and 0.5%. Or no, 0.1% and 0.9%. But okay, I bring example to illustrate every possibility. Okay, example one, for example, I give you, okay, do you understand this or no? You understand what is a skew line or no? A skew line, do you understand what is skew lines or no? No? Yes. I remember in geometry in the high school or no? Okay, do you see my face? Do you see my face? Yes, okay. Look, a Q. Suppose this is a one plane, it's a line. And another plane. Different plane in 3D. No, never intersecting. No. A Q. Clear or confusing? Clear. Okay. Okay. No. I don't know. So you see whiteboard or no? Right now. You see whiteboard? Okay. Okay, ready. Do you understand the concept? Now I put example, different example, and we analyze. How you analyze that? How you analyze that? Suppose line 1 and line 2. Entonces the parametric equation, for example, is given 3 plus 2t. Y is equal 4 minus t. And C is equal 2 plus t. Okay, this is a parametric equation corresponding with the first line. And the parametric equation corresponding with the second line is 6 minus t. Y is equal 3 minus t. And C is equal 4 minus t. Okay, this is the information that's given. I need to determine the location. No? Is intersecting, is parallel, or is a skew line? Well. In this case, I propose you, for example, you take one by one equation. Suppose I take the first equation of the x. I enforce it to be equal 3 plus 2t equals 6 minus t. Okay, entonces 2t plus t is equal 6 minus 1, ¿no? 6 minus 3, sorry. And move 3 to the other side. Entonces 3t equal 3. Wow, t is equal 1. Now, that was for x part. For the y part is 4 minus 2t equal 3 minus t, no? So for t again, is minus 2t plus t is equal 3 minus 4. This is minus t equal minus 1. T equal 1. Wow, it's a coincidence. Good. It's the same value. And for the c value, is 2 plus t equal 4 minus t. Entonces 2t, because I move this to the left, and 4 minus 2 is 2, t equal 1 again. Wow. Okay, see, 1, suppose that this is 1, and this is not 1, so no intersecting. So you confirm that these lines are intersecting because the t is the same. Entonces now, si it's intersecting, it's obvious. Que si my question is, what is the distance? The distance is 0. Because we have a common point. By the way, curiosity, what is the common point? Well. The common point is, I know that t is 1. You plug it in either equation. You plug it in. Es obvio que es 5. Es obvio que es 2. Es obvio que es 3. That the common point is the point 5, 2, 3. And you plug it in the line 1 or you plug it in the y2. 1 is 5, 1 is 2, and 1 is 3. Perfect. Okay, any question? Super easy or no? Intersecting line. No, but this is less than 1% of the cases que satisfy this condition. Okay, all good. Okay, Daniel, all good. Okay, now let me see parallel. 2 new lines. At the beginning you have no idea. Line 2. Okay, line 2 and line 3. Line 2 is x equal the parametric equation, no? 6 minus t, y is equal 3 minus t, z is equal 4 minus t. This is coincident with another example, no? And line 3, no. Line 3 is x equals 6 minus 2t, y is equal 7 minus 2t, z is equal 1 minus 2t. Okay, I try to do my best. I put equation of the x is 6 minus t is equal 6 minus 2t. Okay, entonces minus t plus 2t is equal 6 minus 6. Wow, what the hell is that? T is equal 0. Okay. I put a y equation que es 3 minus t equals 7 minus 2t, no? I solve for this. Let me try. Is minus t plus 2t is equal 7 minus 3. This is t equal 4. Wow, there are no coincidence. So I discard no intersecting line. So maybe we have two possibilities, or it's skew or it's parallel. Pero parallel is super easy to prove because the direction vector v1 in this line is the vector -1. Look at that. It's the coefficients here in front of the t, -1. And the direction vector for the second is -2, -2. Wow. Entonces they are parallel, yes or no? Parallel. Because remember how you prove que two vectors are parallel, you divide the component by component, no? -2 divided by -1 is 2, -2 divided by -1 is 2, -2. Actually, it's the same. So if you divide or you multiply b1, so 2b1 is b2. Or whatever, b2 divided by 2 is b1. So they are parallel. See, they are parallel. Obviously, we have distance. So how you interpret the distance? So you have parallel line, suppose. Line 1 line 2. Guy, so far, everyone follow me? Yes or no? Say, answer me, yes, no. Okay. Thank you, Jocelyn. Entonces, I propose one idea. I propose, yes, okay, Highland 4. Good, very good. Good student I have. You find 1 point on the line, first line. I want to call A1. So let me use a capital. A1. And you find another point on the line. Arbitrary, totally crazy. And now you find the vector here. In between 2 points. Entonces my goal is find this distance. Bueno, this distance look like projection, no? But what kind of projection? Horizontal projection or vertical projection? Horizontal or vertical? Answer me. Horizontal, vertical. Very well. What is the reason que es vertical? It's vertical because vertical is because look, the position for the segment is totally perpendicular to the direction vector. This is B1 vector, this is B2 vector. It's totally perpendicular. Entonces, you apply cross product. Entonces, you understand, wow, it's cross product. But cross product between what? Well, between the vector A1, 1, 2. So this vector A1, A2, doesn't matter. The order is A1, A2, A2, A1, cross product. With the unit vector in the same direction of the line. Are you using B1 or B2? It doesn't matter. Entonces, es B1, for example. Actual value of this. 1 divided by magnitude of this. And this is the famous distance. Okay, projection. Always keep in mind, when it's projection, multiplication, the vector by the unit vector. Si es vertical projection, es cross product. Si es horizontal projection, es dot product. End the story. Now I found the vector. Okay, the vector. Okay, a vector. No. A1 point. Okay, let me go. A1 point here. A1 point is 634. 634. Look here. 634. I assume t equals 0. A2 is 671. Likewise, assume t equals 0. Doesn't matter, guys. If you suppose t equal 1 or t equal another value, it's the same idea. Okay, so you have in my hand 2 points on the line, on the different line, no? And you find the vector A1, A2. Or A2, A1, doesn't matter. You're subtracting the component. Entonces, subtracting the component es obvio que es 0, es 4 y es 3, o negative 3. Okay, es 6 minus 0, 7 minus 3 is 4, and 1 minus 4 is negative 3. This is my famous, this is angular bracket. My famous vector, this. The rest, you know. Who is B1? This is B1. So you put in your algebra, calculator, whatever you want, or by hand, like an antique mathematician engineer, is the cross product 0,4, negative 3, cross product negative 1, negative 1, negative 1. Of course, you find the magnitude of this vector divided by the magnitude B1, que es magnitude B1. Que by the way, magnitude B1 is super easy. Es 1 square plus 1 square plus 1, es radical 3, ¿no? Es radical 3. This is this. Okay, entonces now, after when you compute the cross product, okay, this is a long way. I don't want to repeat again this. It's negative 7, comma 3, comma 4 divided by radical 3. And so you find the magnitude. This guy, the magnitude of this guy is square root 74 divided by square root 3. Approximation. In my labs, you want to express the exact answer. You leave it like that, or your rationalization much better is 4.996 approximately. Okay, this is the long part, but it's a mechanical. It's a mechanical, it's the same. Entonces, si I try to solve for you by hand now, I deviate to the most important concept, que is the understand the basic idea how you find the distance. So basically, let me try to summarize again. We have two lines. We prove that they are not intersecting. No. We have parallel. How you prove that? Because I discovered that vector B1, direction vector B1 and direction vector B2 are parallel. Super. After that, I determine 1 point on the line, 1 point on the other line. Using 2 points, I determine the vector connecting 2 points. And finally, I using the formula for the projection. I realize that this is the vertical projection, not horizontal, and the vertical projection is related somehow with the cross product. So I need to do the cross product between A1, A2 vector or A2, A1 vector, that the unit vector in the same direction of the direction vector of the any line, que by the way is the same because they are parallel. Okay, and this is the long arithmetic part, I know, but this is the answer. Boom. Got it? Any question, guys? No? Confusing? Okay, let me try to explain now skew. Okay, skew is the most popular case. A skew line is the most popular. It's the most frequently, often happen. Suppose line 2 and line 4. Line 2, you know, and the other example. Okay. Okay, this is a parametric equation for the line 2. And the line 4 is different. Okay. Here again, I start at the beginning because I have no idea, no? Okay, so I try, for example, to understand if it's intersecting line or no. Entonces I put an equation for the x, que es 6 minus t, and force it to be 2 plus t. Entonces when I try to solve this equation, wow, what the hell happened here? Well, this is minus t, no? Equal to minus 6. This is minus 2t equal negative 4, t is 2. When you try the y bar, it's 3 minus t equal 4 minus 3t. Entonces we have minus t plus 3t equal 4 minus 3. This is 2t equal 1, t is 1/2. Oof, completely different, no intersecting. Parallel, the vector b1 in this case is the vector, well, we did before, no? Negative 1, negative 1, negative 1. And the vector b2 in this line, direction vector, is 1 minus 3 and 2. No parallel, it's obvious. Entonces es skew. Conclusion is skew. Skew line. Clear? You spend maybe 5 seconds to categorize, classify what kind of deposition we have this. A skew. Let me try to use my skill to understand skew. Okay, skew is to line. Okay, pay attention. This is complicated. Very, very complicated. This is one line. line 2. And this is a Q. Suppose it's like that. But it's hard to see because it's not in the plane of the whiteboard. Okay, so we have two direction vector different, B2. And this is B2 and B4, no? B4, I changed the letter here. This is B2 and this is B4, no? B4. No parallel, B4. Okay. So I can find, as always, one point on the line, A1, a point, this is a point, another point, A2. Now you find the vector between 2 points. But I need to find exactly, I have no idea, I'm totally lost. And what part is the short distance in between this line? I assume it's this. Oh, no, not here. Here. This is the dig I try to look for. Entonces now, si I see one floor plan, okay, this is my eyes. Look in the picture in this direction. I can see, for example, one line like that, another line like that. Of course, no intersecting because this point is in different plane. But this is the vector B, suppose the direction vector B2. And this is the direction vector B4, no? Yeah, I need one vector case because I need to make a projection, but a projection and the one vector gets perpendicular to this. So you perform the, let me try this, understand the strategy, no? The strategy is you perform B2 cross B4. I know that this vector is perpendicular to B2 and B4, divided by magnitude B2 cross B4. And this is the unit vector, but this unit vector is perpendicular to the Now, after that, you find, let me call this vector, I don't know, let me call M vector. If you are now projecting, but in this case, it's no vertical projection, it's horizontal projection. The reason it's horizontal is because this new vector M, I suppose using my imagination, is in this direction or in this direction. I don't know if it's up or down, pointed up or point up. It's parallel to D. Therefore, to find the distance, the famous distance I try to looking for, is a scalar, of course, you perform the dot product between the vector A1, A2 vector, dot product, and vector. Do you understand this idea or no? Confusing or not confusing? Come on, opinion. This is the most important. So you understand this? The problem, the rest of the problem is just arithmetic. It's no big deal. Do you understand this or no? Okay. Yes or no? Confusing or clear? Come on. Opinion? Yeah, of course, I can explain it. Okay. Let me try. One more time. Focusing. 150%. We have two lines. The line are a skew line. That means can never intersect. I have information about the direction vector on both. And the thing to indicate direction vector is B2 vector and B4 vector. If you perform the dot product between B2, B4, or B4, B2, it doesn't matter, the origin. You get a new vector. Okay, this vector is perpendicular to the B2 and B4. So definitely, guys, you need to remember that when you perform cross product in between two vectors, the new vector, I call M is this guy, is perpendicular to this. But it's clear it's clear using our imagination in 3D. Okay, this vector m is parallel to the distance que I try to find, que es d. Therefore, we're using our knowledge of the projection. In this case, the horizontal projection. And the horizontal projection you find using the dot product. So dot product what? Well, dot product of when you're projecting this vector, look, when you're projecting this vector, que es the vector between 2 points, onto the direction of m, you get this distance. It's very hard to see, pero using your imagination. Okay, this is the mathematics. The mathematics open the door to have more imagination. So now basically, the thing we need to do is try to find the vector m, and the vector m is the unit vector and the direction perpendicular to B4. So the arithmetic basic is B2 is the vector -1, -1, cross product, the vector B4, que es the vector 1, -3, +2, no? Divided by the way, let's do it directly, by the magnitude, the vector, this vector. So magnitude of this. So magnitude of -1, -1, cross product, 1, -3, 2. Okay? Magnitude. And this give me a vector. Of course, unit vector, no? And the unit vector is, this is square root 42. Entonces, 1 over square root 42. And the vector is -5, 1, 4. So basically, if you want, let's do it first, the cross product. Give me this answer. And you find the magnitude. This is 25, 1, and 16. It's 42. And this is the vector m. Okay, now I need to find the vector a2, a1. Let's do it. The vector now, a2, a1, or a1, a2. Doesn't matter. No, it's not the same. No, it's opposite sign. Negative. But it doesn't matter. I don't care the direction. The direction is not important. So basically, the point que is involved in the problem is the point A is 6, 3, 4. The point A1, no? The point A2 is 2, 4, 1. Okay, we come from this number. Remember, this number comes from to the coefficient here and the line que have no t, because I assume that t equals 0. This is the point. Therefore, the vector, a2, a1 is 4, -1, 3. Okay, it's 6 minus 2 is 4, 3 minus 4 is -1, 4 minus 1 is 1. And now finally we perform a dot product between m vectors. So the formula is the capital D, the shortest distance between the skew line, is the actual value, the magnitude, of the m vector dot product a2, a1 vector. Okay, let's do it. Well, at least set up. And the rest is, calculator or... Okay, entonces actual value, no, magnitude, I always say absolute value of the vector m, que es 1 over radical 42, -5, 1, 4, dot product, vector a2, a1 is for -1, 3. Okay, and you perform the dot product, and the answer is 3 radical 42 over 14. Okay, remember the dot product, the answer is a scalar. And this scalar give me the distance, the shortest distance between the skew line. And when you put in the calculator, the approximation is 1.39 approximately. Wow, wow, wow. Skew line is complicated, right? Or no? Any question, guys? Okay, see, I try to summarize. It's easy. Look at that. You have two direction vector because we have two lines. You perform the cross product. You find the unit vector in that direction, equal n. You find 2 points on each line, and you projecting this vector onto the direction of n. Of course, dot product because is the horizontal projection, no vertical projection. Okay. Okay. Now, let's see. Let's see the relationship between two different objects. Suppose now I want to find the distance, shortest distance, of course, from point to plane. Wow. To plane. Shortest distance. Okay, so in this case we have two different objects. We have plane and point. Point P and plane pi. Okay, I try to find the shortest distance. This is the distance. Okay, this is 90 degrees. Shortest distance. So you find another point on the plane. Okay, I want to call Q. It's easy. It's easy because well, the basic idea, the equation for the plane, you know, is ax plus by plus c equal d, no? So you assume arbitrary value, totally arbitrary. You suppose x equals 0 and y equals 0. And this part is gone, and you find the c value. And the point is 0, 0, something, comma d over c. So you find completely arbitrary. We have infinity possibility. And you determine the position vector. No position vector, zero, the vector between 2 points. The vector between 2 points. Suppose, so at this point, we have, I don't know, x1, y1, c1. At this point, the coordinate is x null, y null, c null. Okay, so you will be able to find QP vector, es obvio que es x1 minus x null, coma, y1 minus y null, coma, c1 minus c null. Okay, super. Now, what information we have in the plane? We have a normal plane. So the normal plane is also, okay, the normal plane is the most important vector in the plane, a normal vector. Because remember, you define the plane using one point on the plane, maybe Q, and the normal vector. So basically, if you want to find that distance, we are doing projection. But this segment is parallel to the normal plane. Therefore, we're using now horizontal projection. Okay? When it's perpendicular, it's vertical. When it's parallel, it's horizontal. So basically, the formula is you projecting that the distance d is the vector QP dot product, the vector little m, and little m vector is the unit vector in the direction of the vector m. Is m vector divided by magnitude of m. Okay, and you find the distance. Wow, super easy. Plane and point is easy. Entonces now, suppose assume que the equation of this plane, remember, is ax plus by plus cz equal d. Therefore, the normal vector, no uninormal, sino the regular normal, is ABC, no? ABC. Entonces now, what's the formula? Well, the formula is easy. The formula is you multiply this guy times this guy. Entonces, now what's the formula? The formula is the distance, the shortest distance is equal. I know that the time is over, but I want to go fast. Is absolute value a x1 plus b y1 plus c c1 minus d. Who is a, b, c, d? Is the coefficient in the plane. Actual value of this divided by square root, que es the magnitude of the vector. A normal vector, que es a squared plus b squared plus c squared. This is a formula for the shortest distance between the point and the plane. Okay. So students, I know que like so much are fun to using the formula, but no. Suppose que you need to do something, 6 months after when you finish this class with me, you say, well, I don't remember, but it's easy because you have a point. You find another point on the plane. You have 2 points. You find the vector between 2 points. Bang. And you are doing the projection of this vector PQ onto the normal vector M. I know. I remember that when you find projection, we're using univector. Entonces I need to determine si es horizontal projection or vertical projection. It's horizontal. Why? Because the distance, the segment I try to looking for is parallel to the normal vector. Si es perpendicular, es cross product. Si es parallel, es dot product. End the story. Any question? Any question? Do you see my face? Okay, entonces tomorrow no, today.